Angie is a full stack developer at Thoughtworks. She's an absolutely brilliant developer. She loves everything front end. She loves mobile project. She's a brilliant teacher as well. She's currently doing a trainer. She's acting as a trainer in the Thoughtworks University. Now she's going to talk about something related to mobile smartphones, correct? We all use the smartphone. We carry the smartphones everywhere we go. I mean, even to the toilet as well. Currently, yeah. And the idea is that I basically use smartphone just like everybody else. I have apps installed on my software, and pretty much everything I need on a day-to-day basis, I can get it done by using those apps, which is amazing. But that's also put those apps onto the spotlight as well, that just like me, everybody else is using too. So Angie is going to be talking about something called micro frontend. My understanding of micro frontend is just very micro. All I know is that, hey, it's definitely going to help when it comes to scaling the mobile applications or the mobile projects. And I'm really, really keen, just like everybody else, to hear what NGU has to say. And definitely I want to learn from that as well. So with saying that, I'll hand over to you, Angie, and I'll be very keen and very, just listening very intently what you have to say. Over to you, Angie.
Thank you so much, Harsha, for that introduction. I'm gonna start sharing my screen. All right. So as Harsha mentioned, my name is Angie. I'm a senior developer at Thoughtworks. I'm very excited today to be sharing with you the fundamentals of micro frontends in a mobile application context. So in particular, I would like to answer 3 questions about mobile micro frontends. First, why mobile micro frontends? What motivates us from the business perspective to apply this architecture in a mobile world? Second, what mobile micro frontend is? What does having multiple front ends in the mobile context means? Thirdly, how to apply mobile micro frontends? What is the technical and organizational strategy that we need in order to optimize the benefit of this architecture? So let's get started. Why mobile micro frontends? One trend in the front-end world in the last half a decade is the move from web or desktop applications to mobile applications. And this seems to be a very obvious trend because the mobile penetration rate has grown exponentially, especially in the emerging market. The less obvious but equally important factor for the migration to the mobile world is because of the seamless out-of-the-box capability that mobile application has. These capabilities include things like deep linking, push notification, in-app web browsing, and in-app purchases. Well, these features are great from user experience point of view. From business perspective, though, these capabilities are game-changing. They are extremely valuable, especially for companies which business model rely on some sort of or all parts of advertisement. And all these capabilities I have mentioned increase the stickiness of the app. Or in another word, it encourages users to stay within the application and hence be able to use the app for a longer period of time. Also, in the last few years, we have also noticed this trend that we find from our clients. Our clients come to us wanting help from us to develop their own super app. It used to be in the past when our client come to us to help in the mobile space, companies simply want us to build their core business functionalities. So if they are banks, they want us to help their client to see their bank statement, to apply a new credit card, and so on. If they are from an insurance company, they want us to help build an application that help the customer see insurance premium or insurance policy. But it is simply no longer enough to compete in the current digital landscape. Our client now wants us to leverage the existing customer base that they already have, and they want us to increase the engagement. They want us to build other non-essential services. They want us to build an internal shop. They want us to build loyalty platform, their own community space, and even their own wallet. It is certainly a growing and exciting landscape to be in where we are right now. It also means that from engineering perspective, we need to step up to meet this business challenge and these trends that present to us. I see that there are 2 immediate challenges that we face. The first technical challenge that we face is scalability. How are we able to build a much more complex application in the near or constant speed of development? And the second challenge that we face is agility. How can we be able to adapt and make use of the latest mobile technology while still keeping and leveraging the existing code and existing capability that we have cultivated over the years? So to answer the questions I just posed, I would like us to go back a little bit and talk about the brief evolution of application architecture. And I feel like we can learn a lot from how developers over the years have been dealing with the challenge of scalability. So 20, 30 years ago, when we want to create a software application, our architecture would be relatively simple. We would have a thin layer of front end, which task is to present user interface to customers. And we would also have a back-end layer that contains all our business logic. The team structure would be pretty simple as well. We could probably have a relatively small team that deal with the simple client-server architecture. As the requirement from the business expands, the business logic in the backend becomes much more complex and the code base increases in size. And typically, organizations just decide to put more people to handle the expansion. And well, hoping for the best, basically, that somehow, somewhere, the development speed will remain constant as the code complexity and the number of developers working in the same code base increase. But we all know that this is not how it works. In fact, the opposite actually happens. Putting new people with zero context on an already complex system under pressure often slows down the progress of the team. And having more hands touching the same code base with limited context means that the likelihood of merge conflict increases significantly. About 10 years ago, the developer community started addressing this issue arising from monolithic backend with the introduction of microservices, which boils down to the splitting of single backend code into multiple independent services. In this way, people working on them can be split into distinct teams with no dependency among them, which enables scalability to be more easily achieved. It implies that when a new independent requirement comes in, when a new independent business requirement comes in, we can spin up a new service and we can spin up a new team. And the process of onboarding and getting new developers up and running would be much faster because they do not need to get the context of everything in the application. They simply need to get the context of the specific microservice that they are working on. But as we know, the story did not just end here. In the past decade or so, we see the shift of application responsibility from the backend layer to the front-end layer. And this is mostly because of the increased demand of a better user experience, which means there is also a pressure of having a more responsive and more performant front end. This gives rise to the number of popular single-page application frameworks such as Angular, React, and Vue that I'm sure a lot of you have worked with before. But soon enough, the same issue that happened in the backend also happened in the front end, where the front end becomes a giant monolithic application. And beyond just technical issue, from organizational perspective, having monolithic front end also means that we are not really able to split our team into a vertical product slicing. What was, as what mentioned by David and Angeline just now, vertical product slicing means that we split the team not based on front end or back end, but we have developers from the same team working on the both front end and both back end for a focused independent features or focused product lines. This way, when we still have monolithic front end, developers in product team, unfortunately, even though we are splitting into the product lines, because we still have monolithic front end, they still will step on each other's toes in the front end because there are still a lot of dependency among the various teams. And this is where we finally arrive at micro front end, which is one architectural pattern that was designed to address the scalability issue in the front end. So what is micro front ends? This is a quote from my colleague Cam Jackson, who is one of the pioneers that put together the micro front ends concept. In his article, he said that micro front ends is an architectural style where independently deliverable front end applications are composed into a greater whole. Or in other words, micro front ends enable scalability by having multiple front end applications that can be developed, tested, and deployed independently. However, this application should appear as a single cohesive product. So let's take the example of the two different architectural implementation on a website for Thoughtworks. Let's say we have the website thoughtworks.com. When applying the monolithic front end, it is very straightforward. We just have one React application that serves the whole Thoughtworks.com, for example, if we are choosing to use React to serve our front end. When applying the micro front ends architecture, from a user perspective, we will still see the same thing, we will still see a single website of thoughtworks.com. But under the hood, this website is served by 3 different applications. For example, we can have Thoughtworks Office location pages, that is mainly static pages, be served with HTML, CSS, and JavaScript. We can have Thoughtworks offering pages that is served as a separate React application. And potentially this application can be developed and maintained by a different team. And we might also have another pages for Thoughtworkers blogs that is served by an Angular application. The different applications may or may not be of a different technology stack and may or may not be developed by different teams. But the point is, they are independent applications that should be able to be developed, tested, and deployed independently. As a whole, though, they need to appear as one product from a user point of view. At this point, you might come back to me and ask, why would you want to have different stacks? Why would you care about having independent deployment, development, and testing? And it seems like a very complex engineering, and it seems like it's an overkill for a website. And the answer to why we want to do that is scalability and agility. And scalability can be broken down in 2 different perspectives. From organizational perspective, when we have a simple application, having maybe less than 5 people working on it, it may not make sense for us to have multiple teams or multiple code bases. But if we are working for a complex application with, let's say, 10 teams of 10 people each, micro frontends allow these teams to be autonomous. And to be autonomous means that each team is able to make independent technology decisions. Each team should be able to evolve their application according to their own speed. And each team could have autonomy of a release timeline and thus have autonomy of a product roadmap as they are in control of their own deployment cycle. From development perspective, when we have micro frontends, we have a smaller and more maintainable code bases, which means that our code base would be cleaner and less fragile. It will have less merge conflicts. We will have clearer separation of concerns between different functions, and we would maintain our dependency more consciously. In terms of agility, having or using this architecture enables us to upgrade our technology incrementally, which is a tremendous benefit and especially useful when we are working on a legacy monolith application and we want to slowly migrate to a newer technology while still at the same time serving our clients by delivering new features. In the web development, we define micro frontends as multiple frontends application that works as a single cohesive product. Unfortunately, having multiple applications that works as one product is simply not possible in the mobile world right now, as we still rely on platform distributor like Google Play Store or Apple App Store to distribute our application. And they still need to distribute the application as one single entity at this point. And hence, in the mobile world, we define micro frontends as multiple modules that can be developed, tested, and deployed independently, but appear as a single application. And in order to achieve this, we need the application also to look from a UI perspective as a coherent product. And when they are composed of, even if they are composed of multiple modules, we need them to be able to be compiled into a single final application before publishing. So let's now take the example if Thoughtworks have an application that have the same functionality as my example before, the Thoughtworks website. In mobile micro frontends, we can have the different part of the application being developed in different modules. For example, the application can be composed of 3 different functions that is developed by 3 independent functional modules. For example, if we have 3 modules, 1 offering, 1 blogs, and 1 profiles. Similar to our web counterpart, we could develop these modules with different technology. And each module could be owned by different teams or maintained by different sets of developers. And these teams can then decide on their own what sort of technology decisions they want to have. And they also need to decide what is the most suitable decision that they will make to suit their team and their business requirement. And in this way, each functional modules can be scaled up according to their own team and according to the requirement that they have in the team. And ultimately, these functional modules need to be able to be integrated and compiled into a single app before we publish it through the app distributors. The key to micro frontends is each individual functional modules need to be able to be independently tested, deployed, and developed, which means that each of the functional module needs to stand as its own application. Aside from the three main benefits I have mentioned for micro frontends for web, there are also benefits extremely valuable for mobile. Firstly, when we separate different modules, we will be able to develop and test the exact module much faster, as the compile time to compile just that particular module will obviously be faster than compiling the whole giant application, which means that the development and testing cycle would be much quicker. Secondly, we will be also able to test each module independently, which means that if changes happen, we can concentrate on testing a single module. If we need to go to a review cycle or a security review check, we can then just submit that particular individual module for a security check. Next part, let's talk about how we can actually implement mobile micro frontends. So to understand how we can implement mobile micro frontends, first of all, we need to understand what are the typical module architecture that we do. We commonly have three different types of modules that is connected in this form. So the first type is what we call the assembly module. The assembly module is the brain of the operation. This is basically the entry point of the application where modules and libraries are initialized. This module can be thin or can be slightly bulkier and have logic and config inside the module. The second type of module is functional modules. These modules contain independent, distinct functions, which usually correspond to business products. For example, in the Thoughtworks application example that I have, we divided the functional modules based on the app features. So we have 4 different functional modules. The last type is what I call the utility module, which is a common utility libraries that is used across all modules, across different functional modules. These are the common utilities such as notification, authentication, things like network, analytics, and reusable UI components. So these are basically the common useful functions or common useful modules that everyone in the different functional modules are going to use. In this setup, we are able then to add and remove the functional modules without breaking the application. So this is very important to have in this architecture, because it is important that all of these functional modules should be able to also stand as its own app. And in order to do so, we usually have a tiny dummy assembly module that is attached to the functional modules, can be attached or removed. And this is able to help the functional modules to run on its own. And in this way, we are able to then develop, test, and deploy modules individually. And we are also able to have the capability of plug and play. Another known architectural pattern is a 2-module setup that where we combine basically the assembly module and utility module together and pass the library to functional module through either dependency injection or a Kotlin reflection. And this is a less common pattern, as it is mostly work only in native frameworks. Now that we understand how different modules connect with each other, I can share different ways that they can be integrated. One way of integrating the functional modules into the main app is through RealTime Integration. This is actually a pretty platform-specific topic. In the mobile world, whatever framework that you are using, it is eventually compiled down to the native codes. And therefore, the integration points between modules would be easiest done on the native level. We can use common dependency management tools for each platform to help us with module integration. For example, if we are dealing with Android application, we can use Gradle. And in iOS applications, we can use libraries such as Cocoa Pods to compile the functional module dependency and build the application. And with these tools, we can specify which modules we want to be included in the application, which, as I mentioned before, this allows us to have the plug and play capability. Going into a little more details of how we can do real-time integration in Android, we can actually publish each functional module into libraries and store them in a cloud storage. And we can then set the main Android application to fetch the library from the cloud storage when we need it to build the whole application. In contrast, in iOS, we can use Cocoa pods by publishing pod specs into private pod repo, which means that we are not actually uploading the whole library to the cloud like what we did for Android, but we simply publish a specification file to a code repository. And the main app pod file can then be configured to fetch the source code through the pod spec that was published into the private pod repo. And the reason I'm going into a more technical details on these techniques is to illustrate that when applying micro front-end techniques in mobile, there's more often than not, there are differences in technical approach for different platforms, whether we are dealing with iOS or Android. And it is very important to us to understand the differences and the implication of the differences so that we can make the right technical decisions to optimize for the right solution for each platform. And although we are not there yet, I believe the future of micro front ends will, for mobile at least, rely on dynamic integration. And dynamic integration means that when users first download the application, they only download the core-based modules of application. For other functionalities that is maybe not so essential, they will then download the additional modules on demand upon navigating to those functionalities. And in Android, they allow this to happen through a feature called Android Dynamic Feature Module that was just released in 2019. And these capabilities enable the application size in the user's device to be as small as what is absolutely necessary for the user. And from the engineering perspective, if we are able to deploy separate modules on separate timing and be able to decouple those deployments, we will be able to have more control of our deployment and hence a more autonomous teams. However, this unfortunately is not here yet, the capability of doing independent deployment. And we still need to publish everything as a single application and publish them through Google Play Store. But hopefully when Google made this capability available, it is going to be game-changing in terms of mobile micro front ends. So far, we are only scratching the surface really of mobile micro front end techniques that is required for us to build this whole architecture. And I mentioned just now one technique for mobile micro front ends, which is the integration techniques. And there are many other technical approaches that as a team, if we decide to implement mobile micro front ends, it is certainly things that we need to consider and thought out about, like how to actually implement that in the team. But unfortunately, I can't go through each one of these because of the time constraint. And each of the topic is probably very detailed and maybe need their own talk as on its own. So some of the list of techniques that I feel like if you decide to try to implement this architecture that you should consider as a team are things like cross-module navigation, cross-module communication, cross-module integration testing. These are cross-module techniques that is worth thinking about when we are trying to implement this architecture. We also need to think about local debugging, how to do local debugging through doing local publishing. We also need to think about dependency management and continuous deployment, which hopefully will help us to do continuous delivery. And I will be more than happy to answer any questions regarding any of these topics in our Slack channels after the talk. And when we make big architectural decisions, such as applying mobile micro front ends, it is also very important for us to consider how we can set up organizational structure that would support and optimize the kind of discussions and eventually the kind of decisions that we need to have in the teams to play to the strength of the architecture and to minimize the cost of applying the architecture. And one team structure that I would highly recommend it for teams that are interested to use mobile micro front ends are what I call the Custodian Model. In this structure, we basically have multiple vertical product teams, and each vertical product teams will focus on developing features for their own specific product. We will also have custodian team, like a specific team that's specifically charged to take care of the shared code base, which include the assembly module and the utility module. But the custodian team is not actually the final technical decision maker of that modules. The final technical approach should be discussed by all the teams through their team representative during a regular catch-up of all the teams. And with this approach, we will be able to have code base that is more consistent. And we know that the code base consistency will be maintained by the custodian team. And we will have a technical decisions that are decided as a community of teams or as case-to-case basis that is proposed by different teams. We will also create a knowledge sharing through discussions and an increased sense of community and ownership over this weekly sync up. And we can also have the sense of different teams will encourage the code reuse because we have that enough communication to maintain safety and trust. And also we would trust that the custodian team will be maintaining the reusable code. Last but not least, probably the most important one, we would have dedicated developers with specific skill sets from the custodian team that would be the interface for other teams to deal with integration issues. We have discussed the why, the what, and the how of doing mobile micro frontends. And now as a bonus, I'd like to discuss probably the most important questions among all. Why should we, or when should we, or when shouldn't we implement mobile micro frontends? And on technical organizational level, we need to understand that the various trade-off decisions that we need to make in deciding architectural implementation will affect the whole teams. And we will be able to basically balance out between team autonomy and other factors that would affect the quality of the product. The first thing that we need to consider is to balance between team autonomy and team complexity. And this is especially important in a higher level technical decision, such as application framework that we want to use. The more uniform the technical approach across the team, the less complex the integration points of the different modules would be. And this means that if we want to make the technical approach less complex, each team might not have as much independence in deciding their own solution. The second thing that we need to consider is to balance between the team autonomy and code duplication. So let's take the example of having a common component like a header UI component that is used by all modules. It is possible for all modules to independently develop these components because they all are going to use it. And it might even be faster if they just develop it on their own and doing it in parallel. But this will result in code duplication. And all the teams will then need to come together and need to make a decision whether the duplication is acceptable or whether they want to refactor it down to a common library. We need to also balance between team autonomy and product consistency. Product should always be seen as a single vision and have a single design system. And when there is no one maintaining that, it is likely that you would see a glaring inconsistency, things that would obvious, such as having different sizes of text, different color schemes, and this will cost the credibility of the application as a whole. At the end of the day, the way that I think about this balance is, as what the Agile Manifesto has said, we should think about it as people of a process. We need to make a decision that works for our specific team on the specific circumstances that they have. In Thoughtworks application that I used in the beginning, I gave the illustration of using multiple frameworks such as Flutter, React Native, and Native to build one application. And it is certainly possible to do it. And it is one of the very attractive capability that mobile micro frontends offer us. This, however, is very risky and can easily devolve into an anti-pattern called micro frontend anarchy. I wanted to emphasize that using multiple frontends should not be the default setup. In fact, using the same framework and templates for different modules will allow faster bootstrapping for new modules. And this encourages knowledge transfer and creates a larger and deeper specific knowledge pool within the organization. Having said that, there are also some scenarios where it makes sense to have different frameworks. First scenario where it makes sense is when we are moving from a legacy system to a newer technology. But this scenario might actually makes it's more common on web technology because mobile technology are generally pretty up to date. The second scenario where this might happen is when we try to optimize for different skills sets that we have in different teams. For example, if we have two different teams that one team has capabilities on native development and another team have capabilities on cross-platform developments. And we want to make sure that we optimize on those skill sets. The third scenario where it makes sense to have multiple frameworks, if we want to use specific libraries for specific modules that is only available on certain platforms. So for example, in the web, we can do that if we want to use the Python libraries for data analytics for just a specific component in the application. In mobile, maybe we want to use Flutter. We want to use animation library for a specific module of the application. And before jumping out of this talk and proposing this architecture to your team, you need to figure out if this is the right solution for you. First of all, things that we need to consider is what kind of scale of project we are dealing with. How many people are in the project? Does it make sense to break down these people into multiple teams? Are the teams tightly coupled in terms of business requirement? Also, what sort of skill sets do the developers in the team have? We need to understand that when we decide to implement this architecture, although some of the team choose to use cross-platform mobile framework, the integration point need to be done in a native level and need to be platform specific. There will also need to be a cost in terms of development time in setting up architecture and finding out the right integration approach, especially in the beginning of the architecture setup. And also our mobile pipeline will also be a lot more complex than a straightforward pipeline in a monolithic application. In Thoughtworks Tech Leader that was published in May 2020, we put micro frontends for mobile as techniques in trial. This means that we believe that it is a technique that is worth pursuing. And we as the developer community are still actively trying it out and trying different approach that would minimize the cost of implementation. Mobile micro frontends is certainly an exciting technique, and I would recommend it for teams who are more mature and have time and the resources to try out the different techniques. And when done the right way, without a doubt, this is a technique that will benefit you and your team tremendously. With that, I thank you for your attention. If you have any questions, please feel free to ask them in the Slack channel. Thank you.